Well, hi, everyone. I'm Jeff Barg. I'm the head of AI at Clay. And today I'm going to talk about scaling go-to-market agents. So not just running a single agent productively, but what happens when you need to run agents across your entire addressable market at production scale. So first, I wanted to give some brief background on Clay. We like to think of Clay as the creative tool for growth. So put simply, we help you build lists of companies and people from our go-to-market data sets. We help you enrich those lists with 150+ data integration providers and AI agents. And we help you orchestrate those lists into things like CRM enrichment, outbound campaigns, and more. We do this at quite high scale. And so we run over 350 million go-to-market agents every month. We have a proprietary data set of over 40 million companies and 900 million contacts that our agent researches over. And so you can think of Clay as go-to-market infrastructure for running these workflows. So why is go-to-market a hard problem, and why are we running so many agents? Well, we think in go-to-market that no creative advantage lasts forever. And you can think about this from the lens of cold email. And cold email deliverability rates have been going down for the past couple of years for many reasons. But one of them is just the floor has continued to rise. After GPT-4, you can write human-sounding emails. And you can think about this from the lens of your own inbox, where you're probably drowning in a bunch of outbound emails that may or may not be targeted for the things that you care about. So how do you actually win in this environment? And we believe that the fastest to iterate wins. Right? So you actually need to continuously evolve and build new outbound strategies and plays to be able to actually do better than your competitors. And we call this go-to-market alpha. So similar to in finance, where alpha is outperformance against the market, we believe there's a similar concept in go-to-market. So better audiences, better timing, better signals, better positioning than your competitors can yield to actually great results. So how do you actually get to that go-to-market alpha? We believe there's 3 levels. So level 1 is individual AI access and literacy building. So deploying tools like ChatGPT or Claude to your sellers for things like call analysis or outbound copywriting. That's great. But level 2 is actually centralizing that and deploying it across your sellers. So using Claude skills at the workspace level, or after every call, generating post-call notes. Level 3 is creating advantages that your competitors can't copy. So think about we work with a lot of AI coding companies, and many of them build outbound campaigns where they're looking for companies that are hiring for a head of engineering and have a lot of engineers that have started their GitHub repo. So these are plays that are not transferable to their competitors, and they're unique to them, so reaching that go-to-market alpha. We find that many teams get stuck here at level 1. So their sellers might be using tools like Claude to analyze call transcripts or write outbound emails, but it's fairly low leverage because you can write the best outbound email, but if someone doesn't want to buy your product or service, a creative email isn't going to actually change that. Much higher leverage is actually fixing targeting. So finding customers who already want to buy your product or service, you can actually get much more meaningful results. So our best customers really do this using a loop like this. Well, they'll scan their entire addressable market, layer on signals like news articles, fundraising announcements, or bespoke data points like that GitHub stars metric that I talked about. They'll use agents to score those accounts to find out when is the right time to reach out to them and act at that time. Finally, our customers will learn from those outcomes and iterate on those plays over time. So this looks a lot like an engineering challenge because you need to run agents across your entire addressable market. And so that's why many of our customers use tools like Clay to orchestrate this. And at Clay, we have our agent, Claygent, which does a lot of these workflows. So it will do things like company research in order to find out, is this account a good company to reach out to at this time? We run this over 350 million times a month. It processes over trillions of tokens every week. And I'm going to talk about 4 challenges that we've encountered and lessons that we've learned on deploying this agent at scale. The first challenge is on infrastructure, where we actually deploy this in a reliable way. Second is on rate limits and throughput, so being able to maximize our inference capacity without negative impact. Third is on cost. As much as we'd like them to be, trillions of tokens are not free. And fourth is on quality, right? If our agents don't yield meaningful results, then none of the other points really matter here. So we need to make sure that our agents are high quality. First challenge on infrastructure. Now, if you were to profile Clayagent, or probably many of the agents that you all are building today here, most of our agents are actually just spending their time waiting. So they're waiting on, in our case, browsers or APIs or inference. And so we used to run Clayagent on Lambda, and Lambda was prohibitively expensive because Lambda charges for wall time. So we moved that to ECS, but ECS is, we traded cost for reliability. Right? So we needed to re-architect our system to be able to recover from things like random host failure or things like that. And so the right architecture looks actually much more like a durable workflow execution. So using things like queues, checkpointing your agent at periodic steps. So using a tool like LangGraph or Langsmith deployments would help here. The second challenge that we've run into is rate limits. We have a lot of dedicated inference capacity at Clay, but our workloads are fairly spiky, and so we need to be able to maximize the inference that we have in order to productively run our agents. There's so much effort at the inference layer to make sure that GPUs are always hot, and a lot of that gets lost at the application layer unless you're actually maximizing the inference that's available to you. And so we've actually built a system with back pressure to be able to adaptively throttle against our downstream inference providers. And it looks a lot like the TCP/IP congestion algorithm, where we basically will send as much traffic as we can, and as soon as we run into rate limit issues, we'll progressively dial back that traffic. We've found from some of the experiments that we've run internally that this can yield 4 to 10 times as much throughput as a more naive system. So it's actually quite meaningful, especially at Clay scale. We also had to build fairness across our customers because we don't want a single customer who's running millions of agents across their market to crowd out the customer who's signed up for Clay and is running their first 10 agents. The third challenge that we've had to deal with is cost. And cost is meaningful at our scale. We've built our own agent harness at Clay for a variety of reasons. But one of the learnings that we've found from building our own agent harness is that caching strategies have really meaningful impact on the cost of your agents. And you actually can build agents to, against those caching strategies to make sure that you're maximizing that. For providers like Anthropic, this can yield to up to 70% cost savings, quite high. The second strategy on cost that we found is actually bounding retries and tool calls before they sprawl. So you have to do this in conjunction with your evals. But we found that many times, if you force an agent to return after a certain number of steps or a certain amount of research, it will actually yield better results than if you were to let it run to completion. And so, again, you have to do this in conjunction with your evals, but use case specific, this can be quite effective. And the third point is actually measuring cost tied to quality and outcomes, which leads to our fourth challenge on quality. We spend a lot of time on Clayagent quality, and we think it starts with great context. So for us, we give Clayagent access to great web data and proprietary go-to-market data sets. We have an entire team dedicated to making sure that data set is accessible to agents in a great way. We also tune our agent harness specifically for go-to-market use cases. So we have offline evals, but we also have online evals to make sure that our harness is really targeted for the things that people are actually trying to do in our product. And this is, again, where tools like Langsmith are really helpful to understand why or what you're optimizing for. One additional note on quality is that quality is also a product problem. Right? So we built an agent builder in Clay where people can actually test and iterate on their agents before they run it at market scale. And by giving users these kinds of iteration tools, they actually have way more confidence to be able to run their agents at market scale. And yeah, we found a lot of success with this. OK, these are the 4 challenges that we've run into on infrastructure, maximizing throughput, cost, and quality for running these agents at production scale. But what's next for Clay and what's next for Clay's agents? Piggybacking off what I was talking about on quality and context, we really think that agents need great context to do great work. And so we spent the last 6 months or so building a product that we call Audiences. Audiences lets you aggregate all of your go-to-market data into one place. So from tools like Snowflake, Salesforce, Gong, other call recordings, you're able to aggregate all of your data in one place, layer on third-party signals like fundraising announcements, news articles, and more, and give that to Clay agents to be able to run outbound campaigns. Audiences is also the foundation for our agent memory. And we're using this to build what we call go-to-market intelligence, where our agents are actually able to recommend plays based on the things that they've tried before and the context that they have. Right? And so they're able to actually complete this flywheel of improving over time based on the things that have actually worked before. This comes with all sorts of additional infrastructure challenges that we have, things like virtual file systems that are able to actually reason over the context that we have in audiences, things like sandboxes. And if you're interested about these challenges, I would love to talk to you after this. To recap, a couple of things that I've talked about. One, go-to-market is fundamentally an engineering challenge. You really want to optimize your agents for infrastructure, reliability, throughput, cost, and quality to be able to get meaningful results. You need to actually run your agents across an entire market to get great go-to-market alpha. And finally, observability is the feedback loop that actually makes these agents better over time. And with that, thank you. Have a great rest of your day.